Africa is a blessed country. Over and above its rich coal resources, it is also well endowed with non-depletable renewable energy sources, notably solar and wind. According to the Carbon Trust, the country has an average of more than 2,500 hours of sunshine per year, and average direct solar radiation levels range between 4.5 and 6.5 kilowatt hours per meter squared per day, placing it in the top 3 in the world. Since 1994, there's been a significant number of households that have been electrified by Eskom. Rural electrification rates are atypically high, at 77% nationally, compared to an average of 17% for sub-Saharan Africa. Expectations of grid connection and quality of service are therefore high. However, there's still an estimated in excess of 3 million people without electricity in rural and remote areas. Several challenges prevent electrification of the remainder of deeply rural parts of the country. These include the high cost of grid extension of the network to remote areas, the current low income levels of these communities, low density of rural populations, and difficult terrain conditions. Eskom regards microgrid applications as suitable for these geographical locations that are far, difficult, and expensive to reach. A microgrid is a group of interconnected loads and grouping of electricity sources such as distributed energy resources within clearly defined electrical boundaries that acts as a single controllable entity with respect to the grid that can disconnect and function autonomously depending on the situation.
This project, the rural microgrid that's now based in Flicksburg, talks a lot with respect to poverty eradication and universal access to electricity. The system has been built for fit-for-purpose microgrids. So the energy requirements on the system has been taken into consideration when designing the system. And the system has the capability to be rapidly redeployed or added onto should the requirements be available.
The system itself, when we design it, comprises of 3 criteria that would be to be modular, reliable and sustainable.
The Free State demonstration plant is made up of a number of traditional energy components coupled to advanced control systems and technologies. The plant harnesses solar energy and converts this to a peak of 32 kilowatt electrical energy via photovoltaic panels and power inverters. This energy is utilized in 2 ways. The first part of the PV energy is converted from direct current to 220 volts alternating current at 50 Hz frequency. This is the standard low voltage supply